Okay, so hello everyone. And today we are going to discuss Sidestepper, which is a practical way to install malicious enterprise application on a non-jailbreak iOS device. And let's see what we are going to discuss today. So we are going to discuss by talking about the iOS ecosystem. And we are going to discuss enterprise application and why they are so important in the iOS ecosystem. We are going to show you a practical way to bypass the Gatekeeper, which is Apple application App Store. And we are going to finish with conclusion and Q&A. So a little bit about ourselves. So my name is Zohar Bobrov, and I have more than a decade of experience in working and researching in the mobile security field. I was the former CTO and founder of Raccoon Mobile Security that was acquired by Checkpoint last year, and I'm now leading the mobile threat prevention area at Checkpoint. This is my third black hat, thank you. And with me is Avi.
Hello, my name is Avi Bashan. I'm a security researcher for about a decade now. Started in the PC and later on moved to mobile. I was the former CISO and a security researcher at Raccoon Mobile Security, and now I'm heading our mobile dynamic analysis team.
Okay, so let's start. So a little bit about the iOS ecosystem. So iOS is a modern operation system, meaning that every app is being wrapped inside a sandbox. And if we want to access a resource, you need to get the user permission. Another really interesting concept that Apple introduced back with the iOS was that all the code that run on an iOS device need to be signed. And this was a big in comparison to what we saw in the PC world, when anyone could just develop code and execute it on any PC. Another really important concept was the central app store. If you want to develop an app and distribute it to iOS devices, you need to publish it to a public repository, which is the App Store. You cannot do it if you are an anonymous developer. You need to sign and register and even pay money to Apple in order to be allowed to do it. And this was a very radical concept at the time. And so far it's working quite good. And let's say, and one of the main subject there was that Apple do a quite thorough review process when you upload an app to the App Store. And they do both automatic and a manual review of the application. And it composed from many aspects of the application. So they will review the app content to make sure that you are not doing anything that violates Apple policy. They will review the behavior and verify that you are doing what you said you are going to do in the description of the application. They will even find major bugs and verify that you are not doing something that is really ridiculous. And they will check for API abuse. For example, if I will use an API that is not an official API, or if I will use an API that is that I didn't say that I'm going to use, they will block it. And this process is working quite good. Actually, in the last year, there were several major incidents, that someone was able to infect the App Store with the malware, but in general, it's working pretty good. The problem with this process is that it doesn't fit to everyone. And specifically, enterprises had few more needs. So their main requirement was as follows. The first one is that enterprise want to be able to publish application to their internal workforce. For example, I want to develop an app to all of my salesperson, and I don't want this app to be available in the internet because it's only for my internal sales force, and I don't want anyone else to have access to it. The second thing is that the process that I mentioned before, it usually takes quite a while and can take several days. And the problem is that sometimes this time is a little bit too much, and I want to be able to push really rapidly changes to my employees. And in order to solve both of these problems, Apple created what is called Apple Developer Enterprise Certificate, which is a program that specifically aims to solve the enterprise needs and enable Apple to be more friendly for enterprises. And this is a flow that allow any enterprise developer to develop an app and sign the app with a special enterprise certificate. Uh, Purchasing this certificate is pretty straightforward process. You need to have a DNS number, which is quite simple. Every company usually has it. And you need to pay $300 to Apple. Apple still find a way to make their dime. And from that point on, any app can be developed, signed with the enterprise certificate, and then published to any iOS device from the corporate server. You do sign on the contract that you will only sell this application to your internal employees, but it's only control things. And of course, because the app is directly being published from the corporate server to the iOS devices, of course, it doesn't go through any Apple review process. And in theory, it sounds pretty good. It sounds like Apple made a program that solves the enterprise need. But I want to share with you and tell you a little bit what's happening in real life. So the first thing that I want to mention is a case study from one of the companies that we are working with. We have a solution that monitor all the devices in the company, monitor the application and the behavior of these mobile devices. And this is a case study of a US Fortune 100 company that in this specific scenario, we did an initial deployment of 5,000 iOS bring your own device devices, okay? Bring your own device mobile iOS. And what we found was quite surprising. So we expected to find few, maybe several enterprise certificates by the company, maybe by their subsidiary companies. But what we actually found was as follows. We saw that on these mobile devices, we saw around 116 enterprise certificates that used to deploy more than 300 enterprise applications, which was quite surprising. And when we drill in a little bit into it and try to see who issues this certificate, this is some of the list that we got. So as you can see, it's very hard to tell right from wrong. And you might see there a company like Dropbox, okay, that it's still strange why Dropbox will deploy an enterprise certificate application to another company. But most of the companies here are unknown, and you won't be able to tell what exactly they are doing. And we try to analyze and drill into this list and understand why do they have so many enterprise certificate applications. And when we drill in, this is what we saw. So 11 of these enterprise certificates were whitelisted, meaning that it was either the company certificate or its subsidiary companies. And this is a legit scenario. 70 of them had minimal reputation, meaning that we could find something on the company and in some cases even understand what they are doing, but it still was strange why they deploy their apps to another company. 33 of them didn't have any reputation at all, meaning that you couldn't find any reference in the internet or other means of who is the company and what they are doing. And 2 of them were used to deploy malware. Okay, so 2 of these enterprise certificates were discovered to send malware, to use the enterprise certificate to send malware to a non-jailbreak iOS device. And another thing that worth mentioning is that despite the fact that the company is a US-based company, 70% of the certificates, the companies that issued this certificate were from Asia, and only 28 of them were from the rest of the world. So the next question that I think that you should ask yourselves is, why should I care? Why should I care that someone will install an enterprise certificate? As I see, most of them are not really malicious. So let's see what an enterprise certificate application can do. So an enterprise application can abuse public API. So it can use all the public API from iOS. It can use the calendar, the contact, the microphone, the camera. And for example, it can collect all of this information and send it to a server in the cloud. So for example, I can upload your calendar and your location, and when I see that you are in an important meeting, I will just upload, use the microphone to record the conversation and upload it to my server in the cloud. It can also use private API. Private API are API that exist on an iOS device. Usually they are not documented, and Apple doesn't permit you to use them, specifically if you are going through the App Store. But if you are doing it with an enterprise application, you can just ignore it and use this API in order, for example, to take screenshot. So for example, if I have a secure container and I use it to read my email, this enterprise application, this malicious enterprise application can still take a screenshot and upload it to my server. I can also query all the app on the device and use it maybe to a follow-up attack on this device. Another thing that I can do, I can also use an exploit because I have already a code that runs on the device. So I can jailbreak the device. I can use a mask attack. Mask attack was an iOS attack that allows an enterprise application to replace other native app on the device. And I will come back to it later again. So it seems quite scary and seems like an enterprise application can do quite a lot. So what limits an enterprise developer from doing all of these things? So what if I'm an enterprise developer, what limits me from using and abusing all of this capability and use it to do malicious stuff? So unfortunately, currently the answer is basically trust. So I, as a user, need to trust the developer that he won't do it, and there is also a user agreement that I need to approve. But I think that history showed us again and again that relying on a user agreement to prevent malware just doesn't work. User cannot really tell if the application that they are installing is doing malicious thing or just abusing other capability on the device. And I want to share with you a little bit about what is actually happening with enterprise application in real life. Okay, so the first example is shared party market. This is a shared party market is a market that uses the enterprise certificate concept in order to deploy application to its users. And this is and why do we have this market? So one example is that they can take apps, paid apps from the App Store, and on the App Store it will cost you $5. They will take the app, repackage it, and they will sell it to you in $2. Okay, so everyone wins beside the original developer of the app. They can, it's also used if there are apps that were banned from the App Store. Okay, so Apple didn't approve an app, and you will be able to upload it to here. It will also use, it is also used to bypass geographical limitation of Apple, so some applications are not available in other places. And this, because of all of this is not a minor phenomenon. Okay, it's something that is quite popular. And two examples are, for example, 25pp that has more than 40 million users, and allegedly they have 8 million downloads per day. vShare that has 40 million users with 15,000 iOS apps. And of course, although the purpose of this third-party market is not malicious, you cannot rely on them to really do and invest the time and money that Apple doing in order to assure that nothing malicious will get into this market. And this is a major problem as a user because, of course, you cannot rely on the source. But this is still a gray area because their purpose is not really malicious. Another example is using enterprise certificate to really install malware on mobile devices. And in the last year and a half, we have many incidents. This is the most popular incident. We have many incidents of a malware that use the enterprise certificate concept to install malicious iOS application on a non-jailbreak iOS device. And they all use the same concept. You just trick the user to install the enterprise application, and behind the scene, I steal information, I do a phishing attack or other types of malicious things. And I want to focus a little bit about Hacking Team. So Hacking Team is a high-end mobile surveillance vendor, meaning that they develop a mobile remote access Trojan, and they sell it to government agencies. So they will be able to track suspects. And what was funny about Hacking Team is that they got breached last year. And one of the things that the attacker did, he uploaded all of their source code to the internet. And when we investigate and analyze the source code that was uploaded to the internet, one of the things that we can find there was an iOS remote access Trojan. And it was fine to see that they use exactly the same concept to their high-end product. So they used enterprise certificate to install the malware or the Trojan on the victim device. They disguised the application as a news application on the newsstand app. So the user wouldn't notice that another app was added to the device. Of course, they ask for excessive permission. They also install a keylogger so they can track all the keys on the device. And also they leverage the mask attack that I mentioned before. They did it in order to replace many of the native app on the mobile device. And by doing so, they also have access to the information that the original app has. So for example, when you are replacing an email app, you will have access to all the email that was used by the application. And of course, from now on, you have access to all to everything that the app should have. And this was an interesting example. And it was pretty straightforward to install the application. Basically, you just got a null application. You could approve it, and you can see the list of permission that they ask. And when you review the code of Hacking Team, you can see that this is actually part of the source code. So you can see that they are grabbing the new calendar and contact from the device and upload it to the internet. Okay, and this is one example of the things that they did. And at that point, I would like to call Avi, that will talk about MDM and explain to you how MDM fit into the story.
Thank you, Ad. So, you're probably thinking to yourself, Ohad talked with me for 20 minutes about enterprise apps, why I'm coming here and going over to MDMs. So wait a few minutes and everything will fit together. So, MDMs. Let's say I'm an... Oh. Okay, let's say I'm an enterprise and I want to introduce mobile devices to my ecosystem. I need a way to manage them. I need a way to control them. So this is why I use an MDM, a mobile device management platform. This allows me to do a device inventory and allows me as well to deploy security settings on the devices. Let's say as a lock screen, because I don't want devices that can access enterprise data to be without any security policies. I can even do stuff like remote wipe, because if a device is stolen and it can access enterprise data, I want to wipe it. Or even install enterprise applications, as we just talked about. And if we'll talk about how it works in iOS, Apple did it in a very interesting way. Every iOS device has a native support for MDM. And the server, the MDM server, is developed not by Apple, but by a vendor. The protocol, the communication between the MDM server and the iOS device was designed by Apple, and all of the vendors must work with the same communication profile. Meaning, if I go and watch what's happening over the wire, over the internet, I will see the same communication profile, same communication protocol for all of the different MDM vendors. So let's talk now a bit about the architecture of the MDM. So An MDM server cannot initiate a connection to an iOS device. He must go at first through APNS, Apple Push Notification Server. This is a server which is owned by Apple. So the device, the MDM server, when he wants to talk to a device, will send a wake-up request to the APNS server. The APNS server will proxy that command to the iOS device. He's the only one that can start the communication with an iOS device. And now the iOS device will talk with the MDM server, and the MDM server will respond with a command. And what's interesting here is that the communication between the MDM server and the iOS device is not using SSL pinning. And this is in contrast to almost every other iOS Apple service which are using SSL pinning. And this is done in order to prevent a man-in-the-middle attack, meaning the communication between an iOS device and the MDM server is exposed to a man-in-the-middle attack. So if I'm an attacker and I can do a man-in-the-middle attack, and we'll talk how can I do it later on, I can view the commands that are sent from the MDM server to the device. But what's more interesting is not that only I can view the commands, I can even manipulate the commands. Meaning, let's say the MDM server sends a lock screen command, I can change it to a wipe device command, getting another effect, a very different effect on the device. And this is not a new concept. We know about it for a few years. Apple knows about this attack for a few years, but they didn't take any steps to mitigate this issue yet, even in iOS 9. So you're probably asking to yourselves, how can an attacker initiate a man-in-the-middle attack on the MDM? That's a good question. So, how can he do it? He can use something called iOS configuration profile. An iOS configuration profile is basically an XML file which contains various settings. It can contain security settings, it can contain proxy settings, VPN settings, APN, mobile carrier APN settings, and even certificate inside the configuration profile. And the configuration profile is an XML file, and when the device loads this XML file, he displays to the user a very easy set of screens that allow him to deploy the settings. And this is so easy that mobile carriers use it sometimes to deploy APN settings on the device through a text message. And when you connect to a Wi-Fi, sometimes you get requested to install a configuration profile to use the Wi-Fi. And an attacker can use the configuration profile, because it's so easy, to do a phishing attack and install a malicious configuration profile that will route all of the traffic through a VPN or a proxy to its own malicious server, and a root certificate that will allow him to decrypt the traffic. And now that we understood that we have a problem here with MDMs for some time now, and we can attack an MDM and manipulate it, we can go back to enterprise apps. So, as Oad said earlier, enterprise apps are dangerous. They can abuse public APIs. They can access restricted private APIs. And they can even jailbreak a device. And we understand it, and it took some time, but Apple understood it too. And they decided to mitigate this dangerous problem. However, enterprise apps cannot be easily eliminated because enterprises use it. They use enterprise apps. They are invested in this ecosystem. So what they decided to do is increase the complexity of executing enterprise apps. They thought to themselves, if I can make an enterprise app, the execution of an enterprise app harder, it will be a lot harder for malicious enterprise apps to be executed, and most users won't do it. So if until iOS 9, this is the flow in iOS 8 and before, execution of an enterprise app for the first time was very simple. You just got a message box, a dialog box that asked you to trust or not trust the device, and if you trusted the app, it was executed. In iOS 9, it's a bit more complex. When you try to execute an app for the first time, you cannot just trust it. It shows you a dialog box that sends you through a maze of configuration settings. It asks you, it don't really tell you how to do it. You have to guess. And you have to go through a maze of settings. And only after you go for all of those settings, you can execute the enterprise app. And this makes sense because most users won't know how to do it. They won't know how to execute the enterprise app, so malicious apps cannot be executed on the device. But let's think about it. If it will be so hard to execute enterprise apps, how does the enterprise can use enterprise apps? Their IT support will help users all day long. Click settings, go there, will be on the phone trying to help their users to install and execute their own enterprise apps. So Apple left a loophole. What they said is that if an app is installed through an MDM, it doesn't require any user trust. It will just work out of the box. And if we think about it, what they did, they took a mechanism that we know for a few years is compromised. And they let him bypass the new restriction, the new security restrictions they implemented in iOS 9. Meaning, instead of making it better, they made it worse. So now you understand how everything will fit together. I, as an attacker, will set up a malicious enterprise server, a malicious server that contains my enterprise app. And I will initiate a man-in-the-middle attack through a configuration profile. Now, all I have to do is wait for a MDM command to be sent. It takes a few minutes, and every few minutes a command is sent from the server, and replace it to install an app command. The app will be installed on the device and can be executed without any user trust and without showing its origin. The user won't even know it's an enterprise app. Let's see a demo. So, at first, the user will receive a phishing SMS message, text message, that will require him, ask him to install a configuration profile. And as you can see, it's very simple, and the user won't even understand what are the precautions of what he's doing. It doesn't make any sense here. Most users won't know what's happening now, because right now, after we install the configuration profile, this device traffic is going through the attacker server and is exposed to a man-in-the-middle attack. So all the attacker needs to do now is set up his malicious remote server and wait for an MDM command to arrive. And once the MDM command will arrive, he will replace it to install app command. And this command will install an Apple mobile Safari update. And if you think about it, Apple would never let this kind of enterprise app, to go to the App Store, because I, as an attacker, cannot upload another version of Safari. But because this is our enterprise applications and we don't go through Apple's security screening, we can do everything we want. So we will ask the user to install an app. And this is its own corporate MDM, meaning this is not the first time it was requested to install an app. He will do it without thinking twice. And he will install the app. And this is our own malicious enterprise app that accesses restricted user data. And once the user will open the app will start sending malicious data, sensitive enterprise data from the device to the attacker. And of course, won't show this screen to a regular user. So let's do a recap of the attack. So I have an MDM server. The MDM server sends a wake-up request to the iOS device. The attacker intercepts the response from the MDM server and replaces it to an installation of a malicious enterprise app. The app will be now installed on the device and will start to send sensitive data from the device. So we reported this to Apple a few months ago, and we got a response that I think I can sum it up as, this is not a bug, this is a feature. And if this is a feature, I said I'll go to Black Hat and show it to you and hear what you think. So, conclusions. The notion that enterprise apps, that non-jailbroken devices are safe is not true. We've demonstrated here how in the past malicious apps broke to the Apple's ecosystem through enterprise certificates again and again. Apple understood it too, and the security restriction that they implemented could be easily bypassed. And letting enterprise trust the user judgment in order to say if you can install an app or not, an enterprise app that can do malicious stuff, is not something that enterprises can let themselves do, because you can never trust the user with such an important decision. Moreover, enterprises should have a clear way to view if there are enterprise apps installed in their organization. Today, MDM does not supply this kind of features. And in the end, man-in-the-middle attacks matter. Because there is no man-in-the-middle detection in iOS, we can leverage a network attack to get full control of the device through an enterprise app. Thank you. Any questions? SSL pinning will solve the MDM issue, but it will not solve the problem with enterprise apps. It will be a lot harder because of the security restriction, but this doesn't solve all of the problem. Yes? There's no restriction on blocking configuration profile. There are restrictions to block other stuff, but not configuration profiles.
There are many legitimate ways to use the configuration profile, so MDM cannot just block all of them or anticipates all of them.
So where you wait for the platform to validate the speed of that installer?
We can think of a few, but Apple didn't implement them. There are ways to solve this. This is not an unsolvable problem. Yes? the ID is authenticated when you deploy it for the first time, but then you can still, because it's not SSL pinned, you can decrypt the traffic and change it. That's the way the iOS device doesn't know that the traffic didn't come from the MDM server, that it was changed. There's no way to do it now.
Yeah, one of the problems with SSL pinning even is that you cannot just do it because the client was developed and only maintained by Apple, but the server is maintained by many, many different vendors. So currently there is no flow to communicate and pass the certificate between the MDM server and the device. So it's something in the architecture that it's not just adding a certificate pinning that you could do if you're owning the server and the client. Okay, so you need to somehow communicate and pass this information, okay, the certificate. Yeah, yeah.
It's a design flaw. SSL, basic. I'm not sure which one is it now. I think it's implemented in the server side.
Yeah, and actually it doesn't matter because I'm owning the communication between the client and the server. I can just issue my own certificate and just using standard SSL bump technique that you use in your gateway or anything. So it's okay. So thank you very much.